Hello, I'm Chris. This is Warrior. You're invited to an expert session of Warrior where we're talking about cutting edge next generation technology, which not only lowers costs but expedites modernization. And one of the industry leaders with these kinds of technical advances is Bell Helicopter. They're owned by Textron. We have the honor of being joined by one of the cutting edge weapons developers who helped develop the Flora, what you've, I'm sure, heard of, the tilt rotor. His name is Robert Freeland. He's the Director of Government Relations at Bell Helicopter, and they are on the cutting edge, along with a number of the Pentagon's industry partners, looking at modular open systems architecture, ways to architect, design, both modernize and build military platforms for the future such that they can sustain for years ahead. So let's hear directly from our expert, who's one of the top voices in this field. Mr. Freeland, what do you think about MOSA, just in a general sense? Let's just say, even though we're very technical here, be as technical as you want. Our audience is rock stars. They can handle it. What is MOSA, and what are some of its advantages?
Well, Chris, I really appreciate the opportunity to talk with you and your listeners today. So we'll jump right into it. So the modularized open systems approach, MOSA, to an architecture, what that's all about is it's the 5 pillars, making sure that you have your open standards, making sure that you have a way of ensuring compliance and performance. I won't run through all 5 of the columns, but it's very well conceptualized by government what they want to do. And what it really comes down to, and you hit on it, it's removing the burden, whether it's cost, the time, treasure, talent, required for upgrades across the life cycle, so that you continue to have overmatch throughout the life of an aircraft or whatever kind of system on which you instantiate a modularized open system approach. That's one really big part, taking the burden, taking the cost out of upgrading, but it's also managing the obsolescence across the life cycle. People overlook that a lot, but when you have these open standards, when you've actually architected in such a way that you are able to sever, partition, modularize down to whatever level makes the most sense for you. You use the open industry and commercial standards that are published. Everybody has them. Everybody can design to if they choose to. And then you get all the way down into the processing level. Get beyond the virtual and the physical layers into the abstract layers of how you actually move information, how you actually process and get that all out there in a model that is delivered. That opens up all these opportunities.
Well, that's excellent. I wanted to ask you about a text I came across from the Defense Logistics Agency Defense Standardization Program, which specifically takes up these questions of MOSA. And we can talk in a general sense about the technical structure or architecture which helps enable this. Some of the language used by this text is software-defined interface syntax. So how is MOSA accomplished in terms of common standards, allowing new technologies to integrate, and better enabling interoperability?
So let me back that one up just a tad. There's a technical side and a business side to MOSA, right? And it really starts with the architecture framework and the embedded reference architectures, where government in this case, or the customer, whoever that might be, but government in this case identifies, here are the business and here are the technical outcomes that I want. Here are the things that I want to be able to do when you're done putting this together. Well, and then if you take that in prime, it takes that in a good-hearted manner, very honest manner, then what you do is you say, okay, what you need to accomplish these end states on the technical and on the business side is you need to have these open standards that are published that everybody has access to. You need to partition, sever, and modularize down to an appropriate layer. You need to model this whole thing down to the appropriate tiers so that you can, government in this case, accomplish your end states. Now, let's say, for example, when I talk about modeling down to tiers, if I model down to tier 5, model-based systems engineering environment, well, what that means is I need to map the appropriate technical information. So there's IP associated, right? So there's say the technical side, the business side, but you map all this stuff in, all your interface control documents, all your business processes, your manufacturing processes, your coding processes, and you bring all this stuff into the model, and then that model is handed over to the government, so the government can do what it wants with it.
Excellent align. Oh, sorry. Go ahead.
Sorry.
No, go ahead. I'm glad you mentioned it.
Is that then sets the stage for competition across the life cycle. Because when you hand your model over, that exposes you to some risk, right? Because government can pick it up and run with it, or they can hand it to somebody else who has the technical skill and they can go run with it, because all your information is there. So it puts the onus on the prime to continue being a best partner when it comes to architecture management, best partner when it comes to mission systems management, but it also puts a lot of competitive pressure on the old mission system integrators, but now mission equipment providers, who present their units of portability that they remain a proprietary space. If you do sever, partition, and modularize properly, and you build your model properly, then you can still have areas inside that model or inside this MOSA architecture where those mission equipment providers can keep their secrets. You want the mission equipment folks out there. You want them to succeed. You want them to keep being profitable. It's got to work for everybody because they're the 1 + 1 = 3 people. You want them to be able to work their magic, but you can turn their magic into little units of portability that you can pluck out of and plug back into your architecture. You can't have it all wrapped up with proprietary interfaces, very tightly coupled systems. That's what you're trying to avoid. So Bell is very well postured to do this, to be a fantastic partner to government, because our business model aligns very well with what government's trying to do. So, hey, you want it open? So do we. And guess what? We put us in the driver's seat, and we will make sure it's open. And that's an exciting position to be in. It's a lot of responsibility, but it's very exciting, and it allows us to partner with government to make sure the warfighters are going to get what they need, and they're going to remove the burden across the life cycle of getting upgrades and managing their obsolescence.
Roger that. Excellent. Well, gosh, last question would be kind of a bundle of two in one. First is from a purely technical standpoint. When we talk about interoperability, common standards, software-defined interfaces, it comes down to ones and zeros. What are some of the technical elements that enable that? This essay I mentioned talks about, as you talk about as well, publishing MOSA enabling standards. So if we could discuss that for a couple of seconds, and then I have a last follow-up about the advantages and benefits of MOSA long term. If we could tackle both of those, that would be great. Let's start with the technical standards question, the ones and zeros.
Prime and all of our subs have done our jobs and made sure that we incorporated the appropriate flight level information down there at Tier 5. Then government can do what it wants with it, and it can hand that model to somebody else. And there is enough detail down at that Tier 5 level that it can tell them how to code. That's really magic, because the standards the languages are wide open. We just incorporate all of the industry and the commercial and government standards. That's not the challenging part. The challenging part is making sure that there is the interface information, the IP, the processes, the modeling is done properly, so somebody else can pick it up and build to that standard. So the interfaces, that's not the difficult part. We don't really build that stuff. We don't create that. We incorporate that. So somebody else sets the standard, we use the standards. But when it comes to how we architect, how we model, and how we infuse that model with the appropriate technical and business information, that is our job, and that's what we're making sure is done right, because we're naturally aligned. Now,
Well, that's excellent. I mean, I gotta say, the technical expertise in that answer is nothing short of extraordinary, and exactly what we were talking about. And a lot of our expert listeners, way more expert than me, will really benefit from that. And it sets up my last question for you, which is the advantages. Now, the essay addresses this a little bit, but in an operational context or a modernization context, you mentioned cost advantages. There's rapid deployment, there's upgrades, there's interoperability. These are the things cited. One of the things I recall being at ASOL was they used to talk about something, for example, like radar, and software upgrades to radar could enable it to adapt to new threats. So you wouldn't have to go back to the drawing board and re-architect new hardware systems to evolve the platform. That's one of the key tenets of MOSA, from what I understand. And I'd love to hear your thoughts about what kind of a difference this is going to make moving forward to the future of war.
sure. So one of the problems you had in the past is with big programs that took a long time to upgrade. What you bought 6 years ago gets onto your aircraft 2 years ago, and then you bring it out, and you've been training and fighting with that for a while, but it's going to be a couple more years before you get your next upgrade, and that doesn't work. If the enemy is innovating faster than that cycle, then you run the risk of losing your overmatch. And we have to remember that there are a lot of really smart people around the planet, and they can come up with technical solutions rapidly. And if they're compelled to innovate in order to survive, they will. So we have to do the same. And what this comes down to, in this case with MOSA, in the application, when you do your certifications, when you do airworthiness qualifications and certifications, in a modularized open system approach, then what that means is sometimes you have to start with certifying the model, making sure that, and then testing it. And that means that when you're going through your quals and your certifications, you are making sure that when you pluck something out and you put something back in, that the system responds the way you think it's going to respond. Now, just by the way we're architected, we are going to reduce the burden significantly from years down to weeks or months for getting something new on the aircraft. But it can get better than that. And the manner in which we're architecting, if you get down to if you do enough of that work with government in advance, there can be segments on the aircraft where you are so certain of how a new component is going to respond when it comes in, then you can do something within days or hours. That starts to point to what you're talking about, which is even on a big weapon system like this, you can make adjustments from one day to the next. The enemy can try to come up with a countermeasure for your measure, then you come up with a countermeasure by the next morning, and you republish the software, and you're like, okay, well, I figured out what you did yesterday, and now I got you today, and I'll do that again tonight for tomorrow. And that's done properly, which is our goal, our vision, and it requires cooperation with government to make sure that we're doing all these certifications the right way. It might take you a little extra time up front. It might take you, it's not going to be less work to get that level of certification, but you do that right up front, that partitioned airworthiness, the certification qualification certification, then you are going to be in a position where across a life cycle, when you change something, you don't need to redo the whole system. You just do that small area. That's powerful. So I think that opens it up. Now, you add to that, you have an aircraft that is inherently reliable, that you put in a theater so that your burden of producing a sortie goes way down. And now you have a long-range assault aircraft that is quick to deploy into a region. It has the operational agility to move throughout the region. It has the reliability to make it easy to get that aircraft in the air the next day, day after day, at a low burden. And now you give yourself the overmatch. What I can tell you is, when you are looking at a tyranny of distance, the only thing that solves that is having something with the reach, survivable range and speed to get all around that battle space. And when you can do that at a low burden, and you can get very small elements of aircraft in this case, and the soldiers inside them, in disparate location, in disaggregated locations, and at a time and place that you're choosing, you bring them all together and to aggregate into mass. Can't target that. The enemy can't move that fast. So now we're able to do that with this long-range assault aircraft. And by having the modular as open system approach to the architecture, not only will you have the aircraft that is reliable and affordable, but you'll have all the mission equipment for the full life of the program that is overmatched and reliable and affordable.
Roger that. Robert Freeland, Director of Government Relations for Bell Helicopter and Textron. I want to thank you for your time and your expertise. Amazing. Our expert viewers will be edified, to say the least, by this, and I want to appreciate your time. This MOSA, according to the Pentagon, is the standard moving forward, and as one of the developers of the FLRAA, the tilt rotor, this is the cutting-edge stuff that we appreciate. We're honored to hear from you, sir.
Well, Chris, I appreciate that. I appreciate your listeners. And it's not only a Pathfinder program for the Army, it's gateway for the Department of Defense. So Bell Textron Incorporated and our partners are very proud of it.